Let us now see how to solve geometrical problems involving the intersection of lines and circles. Now, before we go into problem solving, let's recall the symmetric properties that we have learned, symmetric properties about circles that we have learned in our earlier chapter. Now, if you remember this particular property, the perpendicular bisector of chord. For this property, the symmetric property of circle, what does it tell you? Now, if I have a chord, specifically a chord that passes through the center, right? A chord that passes through center and is perpendicular to a chord that I have in a circle. So say this chord is A, B. All right, if I have a line drawn past the center of circle and is perpendicular to the chord AB, we know that it splits our AB into two equal halves. Specifically speaking, this point here, all right, is actually the midpoint of AB. Midpoint of AB, not midpoint AB, midpoint of AB. Now, not only does it split the two into equal halves, all right, if I have perpendicular, essentially, if I know the coordinates of A and the coordinates of B, I can find the midpoint of AB. If I know the coordinates of A and B, I can also find the gradient of AB. And since I know it is perpendicular, the line that I draw is perpendicular and passes through the center, we will know the gradient of this line here as well. This green line that we have. All right, so note a few things. One, the perpendicular of the chord splits. If we have a perpendicular bisector to the chord drawn, we know that the perpendicular bisector passes through the center of the circle. All right, the perpendicular bisector of the chord splits the chord into two equal halves. In the diagram case, it splits AB into two equal halves. We know that it passes through the midpoint of AB. We know the gradient of AB. We can therefore also know the gradient of the green line there. So essentially, if I have to, I know that gradient of this particular perpendicular bisector is actually -1 over gradient of AB. Right? Bearing these few things in mind, let's go to some examples. And I thought for circle questions, it would be wonderful if we can draw the visual out, we can sketch the visual out, so that gives you a very clear picture of where you are and what you want. What do I mean? In example 1, find the equation of a circle which passes through the points 5, 0 and 3, 4, namely A and B, and has a center lying on the line 2y plus x equals to 4. Wow, quite a mouthful. Now essentially what the question is saying, I have this particular circle. All right, and this circle has 2 points, 5, 0 and 3, 4. Okay, for benefit, let's draw along the axis. I do not know, but this is just a sketch, so I'm going to put it in. I know I have a point 5, 0. 5, 0 means it's actually sitting on the x-axis, 5, 0. There's another point 3, 4, so 3 got to be a little bit here. Okay, say I place this, I have this point 3, 4. All right, I have this chord done. And if I have center of circle, all right, if I have a center of circle, I know that the center lies on this particular line, 2y plus x equals to 4. So if I have, very quickly at a glance, 2y plus x equals to 4, I'm talking about 2y equals to negative x plus 4. So I'm talking about y is actually negative half x plus 2. With this in mind, if I have to sketch the line in, I know this line passes through the center. It's a negative sloping curve and it cuts the point 2. So it could be something, say for example, like this. All right, this line here is your 2y plus x equals to 4. Okay, so 2y plus x equals to 4 over here, the green line. I have a center. I know that if I draw a perpendicular bisector from the center to the chord, if I draw a perpendicular bisector from the center to the chord, this essentially splits this into two equal halves. And if I know the equation of this perpendicular bisector, and I know the equation of the green line there, if I solve them simultaneously, I can actually find the center of the circle. All right, so I'm going to work this out. Now, first and foremost, to start off, let's find the midpoint. All right, we can start off by finding the midpoint of AB. Because I know midpoint of AB sits on the orange line. So midpoint of AB, I have 5 plus 3 over 2, 0 plus 4 over 2. So if I talk about the midpoint, I know I'm looking at 4, 2 as the midpoint for the point AB. So this point here, 4, 2. All right. To find the gradient of the orange line, all right, my purpose is to find the equation of orange line. To find equation, I need to have at least a point and a gradient. So I found a point. Now I'm finding equation of a gradient. So to find gradient of the orange line, I will need the gradient of AB. All right, gradient of AB, I have 4 minus 0 over 3 minus 5. Gradient of AB essentially is negative 2. So therefore, gradient of the perpendicular bisector is equals to negative 1 over negative 2. So that makes it half. With the gradient, with the point, all right, now I know that the equation of the perpendicular bisector, all right, the equation of perpendicular bisector essentially is y minus 2 equals to half x minus 4. All right, so that's y equals to half x minus 2 plus 2. So minus 2 plus 2, that leaves me with plus 0. So let me erase this. All right, the equation of perpendicular bisector is y equals to half x. I know the equation of perpendicular bisector, the orange line now. I have the equation of the green line. If I solve them simultaneously, essentially I will be able to find this red point, which is also the center. So let's go solve them simultaneously. Call this equation 1. From the question, I have 2y plus x equals to 4, and I'm going to call this equation 2. Okay, by substituting 1 into 2, I get 2. Oops, I don't want y anymore. I'm going to substitute in half x plus x equals to 4. So this is x plus x, so 2x equals to 4, x is equals to 2. Knowing x equals to 2, y is equals to then 1. So now that you know x and y, you know that the center of circle is equals to 2, 1. As requested by the question. Oh no, the question didn't ask for the center, the question asked for equation of the circle. So with this in mind, to find equation of circle, if I know the center, it is not enough. I need to know the radius. So I now know that the center of the circle, this one here, let me shrink this page a bit. I'm going to expand it later. I know this is 2, 1. The center of circle is 2, 1. In order to find the radius of the circle, I can choose to take this one here. This is a radius. This is also a radius. This can be the radius, but I do not have this point here. All right, but definitely this dotted line one is not a radius. It's just a perpendicular bisector. Okay, radius means from center you have to touch all the way to the circumference. Okay, so let's go find the length of radius. Length of radius, I'm sure by now you know the distance formula. All right, so if I were to find radius, all right, I'm going to find this. I have my 2 minus 5 square plus 1 minus 0 square. So that's square root 10. Aha, now with center with radius, I can form up the equation. Equation of circle. Therefore, it's y minus, equation of circle. The general form I can write as x minus 2 square plus y minus 1 square is equals to actually square of the radius, which means it is x minus 2 square plus y minus 1 square equals to 10. The question didn't specify which form to leave the answer, so we are okay with leaving this as your answer.